And we had just the one line here, and the trucks kept coming way over to one side or the other, trying to avoid the camera. So then I put in extra lines. I put in the double lines here, and they still drove over one way or the other. And I need them centered over to the infrared camera so I can get both brakes because I use a wide angle lens. So anyway, I put in the speed bumps to force them to stay centered over the camera, and this worked pretty well. But the problem with the speed bumps is when it's snowing and stuff, the snowplows take them out. So we're going to grind the divots into the road instead of the speed bumps in the future. Then I had a problem with how do I detect where the axles are. So I invented this system here so I could detect the axles in the truck. We were using the magnetic loop technology, but it kept losing them on the slow ramp. Magnetic loop needs about 30 miles an hour, and the trucks stop and go here, and sometimes they go fast, sometimes they go real slow. So I came up with this infrared beam system, and you'll see in the presentation, but there's 3 emitters over there and 7 receivers over here. So 3 of the receivers pick up one frequency, 3 of them pick up another frequency, and then 1 of them picks up another frequency for the axles. So anytime a truck goes through there, it breaks the beam, and we know we have a truck, so the minute it hits the bumper, it breaks that beam, and it stays broken for the whole length of the truck. And because it's light, the instant the truck passes, we know the truck's passed. So if they're tailgating, it doesn't matter. We still get each truck separately, which is the problem with the loops. The loops, when they're tailgating, it looks like one truck to the magnetic loops. So anyway, and then I needed a way to detect where the brakes are, because we didn't want to just scan the whole truck, we wanted to scan the brakes. So I put in another beam that's focused. It's more like a pencil lead beam, and it goes across at 3 inches off the ground. So every time a tire passes, it trips that beam, and then it takes a picture of the brakes. So it works out really well. We even had a bicycle go through here the other day, and we got him. The infrared camera's in the box there.
You mean this in the middle?
In the middle of the road, right. And it's got a 1/2-inch steel plate top over it, as you can see. I put the ramp in there because when I bought the enclosure from Fleur, it's a big enclosure. It's 7.5 inches, and the camera's only 4.5. So I had to bring the camera up out of the ground for it to see. So I had to put that. I had to either make a bigger hole for it to see out of, or I had to raise the camera up out of the ground. So that's why we have the ramp like that. As you saw in the station there, I've got a new enclosure that I built with clear glass, and it's got a smaller germanium window, and it's the same size as the camera is basically. So when it's being flat on top, I don't have to bring it all the way out of the ground. So I built a new enclosure that I'm getting fabricated right now, and it has a totally flat top on it. So it's not going to have that elevated ramp that keeps getting hit all the time. We found that 4 hours after we put it in, we had lowboy trucks hitting it. So even though it's only 3 inches off the ground and they're supposed to be higher, they still hit it. But and then I put a sliding door on there, so the sliding door is 1/2-inch plate steel, and it automatically opens with the software. So when the officers open the software, it opens that door up, and then it raises the camera up out of the ground and turns the camera on, and then these processes start. And when they're done, they turn the software off, the camera goes back down in the ground, and then the door closes to protect it from vandals and stuff. So anyway, that's basically how that works. I can show you the controls and stuff if you want to see those.